Assalamu alaikum class. Today we are going to discuss R square and adjusted R square. We are going to see if we have adjusted R square, then why we need adjusted R square. This is a comparison between R square and adjusted R square, and we are going to learn what is adjusted R square, why we need adjusted R square. So one of the property of R square is that it is a non-decreasing function of the number of explanatory variables or regressives that are present in the model. The number of regressors, that is axis variable, increases, then R square almost invariability increases and never decreases. So R square is a, which means that if in a model we increase the number of explanatory variables, R square also increases but never decreases. The formula of R square is explained variation over total variation. These are some alternative formulas. We normally use this formula in our literature. Okay. Now, R square is a measure of goodness of it. I already told that. It tells how the variation in the response variable y is explained by the independent variables in the regression model. Independent variables are axis variables. Now, we compare, if we want to compare two regression models with same dependent variable, but so with different number of explanatory variable or independent variable. Let's say for first model there are two independent variable, and for second model we have five independent variable. Then how will we compare these two models? In this situation, R square is not an appropriate measure because there are two independent variables, there are five independent variables. If there are two independent variables in the first model, if two independent variables in the second model, then we can compare the two regression models. But this is not the case. So in this situation, we want another measure which will see or take into the account these two uh, things, these two variables, independent variable. Next slide. Now here you can see that there are independent variables k, number of regression in the model. We consider an alternative coefficient determination, also called adjusted R square. Adjusted R square for the explanatory variable is, this is the alternative formula. Two formulas here. Yeah. This is this formula is just simplification of this one. Now there is another alternative measure called modified R square. This, if you can use this formula, you can also use this formula. Two alternative formulas. Now we are going to learn the estimation of parameters. There are two commonly used methods: method of least square and method of maximum likelihood method. And in regression model, we have two constants, A and B, where A is called the y-intercept and B is called regression coefficient. Now, what is the difference between these two methods? In least square method, we minimize the sum of square of residual, but in maximum likelihood method, we find the maximum value of the joint distribution of parameter, joint distribution or any function of parameters, which is explained in the next slide. This method of least square, was proposed by two mathematicians, Gauss and Markov. This method is based on the theory of linear estimation. The basic theme is behind the method is that an estimator found by minimizing the sum of square of deviation of the sample size from a function that has been hypothesized as a fit of the data. This is called the estimator, which is we are going to estimate. This estimator is called the least square estimator. Uh, Now we are going to see how can we estimate the parameters of the regression model. As we know that the regression model is this. Now by separating errors and taking these values on the left side of the equation, we have this model. Now these are errors. Now taking squares and summing on both sides, we have this. Summation ei square is equal to summation y minus a minus b xi whole square. Now we are not going to expand this square, but we are taking partial derivative with respect to a and b and following are the equations. This is equation 1. Now here I am not going to explain how to take derivative because I assume that you already know how to take partial derivative and derivatives because you have already taken the course of algebra by Professor Rauf. Now this is for A and this is for B. Now this is the derivative of base. This is the derivative of base. And the derivative of this base with respect to A should be minus 1. And the derivative of this base with respect to B should be minus x. Now equating these equation equal to 0 and simplifying we uh, following equation. These two equations are also called normal equations, and by solving these equations by cross multiplication method, um, we have following results. I am not going to explain the cross multiplication method because I assume you already know how to solve these two equations, two unknown parameters and two equations. This is the value of b by simultaneously solving these methods, and a is here. Now you are wondering, this is not the formula we used earlier. We use this formula. This formula can be obtained by dividing this equation by n and separating a, we got to the this result. Now this is end of today's lecture. In next lecture we are uh, going to learn method of maximum likelihood in the next lecture. Thank you very much.